It's your 4.2 calculus mean value theorem video. So to start with, you're going to be solving problems involving checking the mean value theorem, doing roots, which are zeros, finding functions from derivatives, and finding position from velocity or acceleration. So as you may remember from physics, whenever you had that, you have position, like as an example would be meters. You have velocity, which would be meters per second. And you have acceleration, which would be like meters per second squared. Now, related to math, we're doing the derivative of velocity is position. And the derivative of acceleration is velocity. Now, what we're about to do is find out where it increases, which means it goes up from left to right, and where it decreases. So the increases is the one like that, which is like positive slope, but it could just be generally increasing but not be straight. And like in decreasing, it could be like that, like a upside down square root. And it's over a specific interval, which could be open or closed. This section gives a test to determine where it increases and decreases, and we also show how to test the points that are called critical points to determine whether the local extreme are present. Now remember, a critical point exists if the derivative equals 0, and that could also be a maximum or a minimum on the graph. So those were the two ways to get it. So when we're talking about increasing and decreasing functions, the corollary to the mean value theorem says if it's positive derivative, it's going to be increasing. So then you know it's going up at that particular section. And if it's negative, it's decreasing, which means it's going down. So we do know that attribute about it. A function that's increasing or decreasing on an interval is said to be monatomic. I think that's supposed to be is not increasing or decreasing. Yeah. Is not increasing or decreasing is monatomic, because that's like boring because it's flat. Okay, so then your corollary is if the derivative is greater than, then it's increasing, and if the derivative is less than, then it's decreasing. And usually we pick C to be an easy point. So, for example, if you have an interval like 1 to 3, then choose 2. If you have an interval like 0 to 1, then choose 1/2. Just make it somewhere in the middle, so to speak. Make it easy to test. Now, sometimes use 0 or 1 to test, because that would be kind of simple. Sometimes use 2. It just depends on the function. Okay, so for the first derivative test, it tells you that the critical points locate where it's increasing and decreasing. The first derivative changes sign at a critical point where the extreme occurs, which was where it's the max or the min. So suppose C is a critical point of a continuous function and that f is differentiable at every point except possibly at C itself. Moving from left to right, if it goes from negative to positive at that point, then it's a minimum. And if it's positive to negative, it's a max. So those look like that in general. It doesn't necessarily have to be a parabola, but if it goes negative to positive at C, which I'm going to call those points, then that's where it changes direction. And if it does not change sign, then there's no local extrema. So you could have something like that. And look at the graph and choose points. Okay, so to begin with, you have a particular function, and we can say this is A and this is B. And we want to find f of B minus f of A over B minus A, because that's what the derivative is. And so to start with, we'd say, what is f of B? Well, f of B means f of 0. And so then we plug that in and we get -3 basically. And then if we do f of A, that means f of -2. And so on that one, we do 5 times -2 squared minus 2 times -2 minus 3. So that's 5 times 4, which is 20, plus 4 minus 3, that gives you 21. So now that we have our individual parts we can plug into the formula, we're basically doing f of B minus f of A over B minus A. So this is like your slope, and your f of B we figured out already is -3, and our f of A we figured out is 21, and then we do our B minus A, which is 0 minus -2. Now that gives you -24 over +2, which is -12. So that's your first step. Your next step is do your derivative. So if this is your function, your derivative would be the 5 times 2, which is 10, lower by a power, and just use your slope. And that's basically it. So then that means we have 10x minus 2 equal to this number, -12. Then we're going to add 2. So 10x is -10 and x is -1. So that's what we wanted. Now, as an alternate way on the very first one, remember that if your interval is like thinking of it on a number line, -1 is in the middle of it. Now the problem is, as you can see on this one, if you have 1/7 here and you have 7 here, it's not the middle, because our answer looks like it's going to be 1. And so you can't always just take the middle. So be careful about that. So just because something happens for one problem doesn't mean it's going to happen for the other. But what we are going to do now is do f of B, which means f of 7. So that's going to be 3 times 7 plus 3/7. So 3 times 7 plus 3/7 is 350, 150 over 7. And f of a means do f of 1/7. So that's 3 times 1/7 plus 3 times, or 3 divided by 1/7. Now on this part, if you're working it out, it's 3/7 plus 21, which is actually the same number. Now when we do our derivative, originally we would write this as 3 over x as 3x to the negative 1 and do our derivative. So that'd be like this. We say the derivative of 3x is 3, and then you do your exponent times your coefficients, negative 3, and then lower by power. And then that is what you're going to set equal to our number. Now, in this problem, we have f of b minus f of a over b minus a, which is going to be 150 over 7 minus 150 over 7, divide by 7 minus 1/7. Well, that's going to give you 0 in the numerator and 6/7 in the denominator, so that's just going to be 0. So when we set this derivative thing equal to 0, then we're going to add 3x to the negative 2 to both sides, and it's going to turn positive. You still have a negative coefficient, but it's going to turn positive. And then we divide by 3, and this is 1 equal x to the negative 2. So remember, that means it'd be 1 equal 1 over x squared. Well, that means x could be plus and minus 1. Now, in our example, our interval says it has to be between 1/7 and 7. So use 1 since it has to be from 1/7 to 7. You cannot use the negative 1 answer because that doesn't fall in that interval. So that's why it's 1. Okay, now on this one, it's going to be the same approach, but it's a little trickier. You're going to have decimal answers on this one. And let's first do the step f of b means f of 1, because this is a, this is b. That's just going to give you 4 plus 8, which is 12. And when you do f of a, that'd be f of negative 2, which means 4 times negative 2 cubed plus 8 times negative 2 squared. So you could type that like you know, or you could like use your mind if it's quicker. Like 4 times negative 8 plus 8 times 4, that's negative 32 plus 32 gives you 0. So then for your formula, f of b minus f of a over b minus a, that would be 12 minus 0 over 1 minus negative 2. So that's really 12 over 1 plus 2. 12 thirds is really 4. So 4 is our first step answer. Now, the next step is you have your function is 4x cubed plus 8x squared. That tells us that the derivative would be 12x squared plus 16x. Now what we do is we set that equal to 4. Now, on this one, we're going to bring the 4 over. And what I notice on mine, at least, is both, or all three terms are divisible by 2 because they're even. In fact, all three terms are divisible by 4. So what if I factored out of 4? Then I'd get 3x squared plus 4x minus 1. And then we divide by 4, and so we're left with 3x squared plus 4x minus 1 equals 0. Now, unfortunately, this one's not going to be factorable. And so you have to use the quadratic formula. So that's negative b plus or minus the long square root b squared minus 4ac all over 2a. And so our a is 3, our b is 4, and our c is negative 1. So that's going to be negative 4 plus or minus the long square root 16 minus 4 times 3 times negative 1 all over 2 times 3. And then we have to break that down, simplify it. So let's do this part. This is how I'd normally type it. 16 minus 4 times 3 times negative 1. That's 28. So what that means is negative 4 plus or minus the square root of 28 over 6. So we're not simplifying square roots on this one. So if we just do negative 4 minus square root of 28 over 6, we can get a decimal. And if we do negative 4 plus square root of 28 over 6, we get a decimal. So remember to use parentheses. Negative 4 minus the square root of 28, all that divided by 6 as a decimal. That gives me negative 1.485. And they want you to round to make it, oh wait, I left out a 5. Negative 1.548. So that's your negative 1.549. And on the other one, if I just need to change this to plus, I get 0.2152. And so I just want 0.215. So those are your answers. So that matches what we want there. So the main step is do your f of b, do your f of a, find your slope, do your derivative, set it equal to your slope, and then from there you had to do the quadratic formula. So that's a good start on the first 3 problems. Hope that helps.